Welcome to a presentation by the Australian Delphi Users Group that was shown at our 2023 Symposium. Our forums provide a resource where you can ask questions and receive answers about Delphi. There are many experienced Delphi users who watch our forum and provide helpful answers to your questions. You can also show your knowledge by answering questions that others may have. Attendees of the symposium have access to a 2023 symposium category, which is where you will find information related to this year's symposium. This will include the videos, links, and content provided by the presenters. The Australian Delphi Users Group has regular local meetings in Melbourne, Sydney, Perth, Brisbane, and Adelaide. Many of these meetings can be watched online via Zoom. Watch the meetings category in the forums for announcements of upcoming meetings, information you need to know to go to them, and what topics are going to be discussed at the meeting. We would like to encourage everyone who is able to attend our meetings to learn and network and meet up with other developers like you. We are always looking for people to present topics, and we are sure there are many people watching who have unique expertise that others would be interested in knowing about. This year's presenters are Jeffrey Smith, Jason Tolley, John Asenden, and David Millington. We would like to thank our sponsors for supporting this year's symposium. We would also like to thank our prize donors who have provided us with excellent prizes for attendees to win. Now, without any further ado, here is one of our symposium presentations.
All right. Hello again. I'm going to talk about WebAssembly, also known as Wasm. Why this topic? So since about October last year, as part of the committee, we've been planning this symposium. And the way it works is we suggest a whole bunch of topics and speakers, and over the course of several months, we basically reduce that down to what we have today based on speaker availability. Glenn Clyden was actually going to be one of our speakers. He's not able to be here today. So hi, Glenn, if you're watching this. And so when this topic came up, I basically suggested it as I thought it was something interesting. I'd done some research and learned that you could actually create something called a Wasm bytecode or a binary and actually run it in a browser. That was really the level of knowledge that I had. And I'd also learned that you could do it in Object Pascal, and you could use the free Pascal compiler as part of that tool chain. That was about the level of the pitch to the committee, and I kind of quietly crossed my fingers that I wasn't going to get picked. Not really, but here I am. And so I mentioned that just because of, if you like, my starting point. And secondly, I've got big shoes to fill in terms of our previous presenter. Well done, Jeff. And really, this has been an exploratory exercise. I'm not a Wasm expert. There's lots of traps in this whole world. For me personally, why I'm interested in Wasm is ever since Java came out in the late 90s, I thought, wouldn't it be cool to write something once and run it anywhere? Whatever the language of choice is that you have, wouldn't that be amazing? And at the time in the late 90s, I invested significantly in learning about Java, in toolchain, and those sorts of things. That didn't really work out. In my assessment, Java is not a great platform anymore, particularly with the Oracle purchase or takeover. And one of the reasons I liked Wasm was because it supported multiple languages, which I'll talk about a little later. A lot of languages, actually. So we have the possibility of writing in whichever language we like or are most familiar with or have a code base in, and creating this portable bytecode that can be run in multiple locations, including a browser and including on servers and devices, which I didn't know at the time. It is standardized. It is part of the W3 consortium since 2019, I think it is, and it's not JavaScript. And I underline that because I don't particularly like JavaScript. I find it extremely tedious, fragile. I don't think it has a great place, or it shouldn't have a great place in our enterprise computing world, at least that it does. So these are the reasons why I was interested in Wasm as a technology. The way I thought it was going to work, prior to spending several weeks on learning what I could about Wasm, is I imagined it was going to look like something like this. You have a HTML document, which holds your user experience, user interface, your buttons, your menus, those sorts of things. And sitting behind that is this compiled bytecode.wasm object. And it all just fits nicely together. And the reason I had that expectation was based on previous experience. Macromedia Flash, very nice, very simple, right? The object tag in HTML. Java, again, an applet tag, very nice and elegant. Silverlight, remember Silverlight? Again, a set of tags within the body of a document that gives you these objects. But what I learned is it doesn't work that way, at least in a browser, not quite. And I'll come back to this, this topic again. So let's take a look at the actual Wasm technology. So it's called WebAssembly. It's abbreviated to Wasm. It's a binary instruction format for a stack-based virtual machine. It generates a platform-independent bytecode, very similar to what Java does, very similar to what .NET does. It is an open standard, though. So that is something that's interesting, I think, for us. As I said, it supports multiple languages as a compilation target. So in free Pascal, for example, rather than targeting a particular CPU, like an ARM or an x86 or something like that, you're actually targeting a Wasm as an output. The other environments that I've looked at, C toolchains and so forth, do a similar thing. We can deploy to a browser and server and desktop. And I actually, at the time, I didn't realize that it was actually quite easy to run a Wasm-based binary object as a process in a command line environment, for example. So I think it opens up a new possibility for clients and other server applications. As I said, it is a standard. The other interesting thing about this, coming back to the browser, is when you look at the matrix of all the browsers and all the versions with their Wasm support, it's basically universal. So in terms of creating an application or a piece of code that actually runs universally across all the browsers, unaltered, which is not the experience you have with JavaScript, that was interesting. And it's a sandbox secure environment. So in actual fact, the first projects that I started creating, and the simple projects, are actually quite restrictive in what you can do. You can't actually access the underlying operating system or sockets or anything like that. It's more like a simple DLL model. It does run at near native performance. So some of the things that we're seeing, or I've seen in my research, is that people are taking time-consuming JavaScript code, functions and libraries out of their web client-based applications and replacing them with Wasm because of the performance. And I've got an example of that a little later. So this is the interesting thing for me, is the supported languages. Again, going back to what language we like, what language we have an investment with, and creating something that's cross-platform. I think that's really interesting. So there's a bunch of languages here. You can compile from JavaScript to Wasm, which is interesting. And then we've got some others here. Pascal, of course, is what we're interested in. TypeScript, which is Apple's kind of JavaScript technology, has been replaced by an assembly script open source project. So the syntax and the tool chains are all very similar, but it's called assembly script. So you can actually convert assembly script / TypeScript to Wasm also, and Python. So around the Ruby, PHP, Python, there's possibly an opportunity to do some more server-side application development using Wasm. So some of the key concepts I want to share and that I've that I've had to learn. As I said, this has been a really intense, maybe is the word, sometimes frustrating learning experience. It is kind of bleeding edge. It's not what I would call a mature technology, but I do believe it has some really interesting promise if people continue to invest in it, particularly the vendors. So we start with a source code file, which is a .wat file as the file extension. It's just plain text. Essentially, it's like the equivalent of assembler. It's not really designed to be human editable or human writable, but just like assembler, just like writing in mnemonics, you can actually create Wasm applications using a WAT or a WebAssembly text file. From the text file, just like in all the other similar technologies we know and are familiar with, we convert that text file or that source file into a bytecode. That's our output. We don't generate a binary as we know it. It's a bytecode that then is loaded into some type of runtime environment. And again, the compile target is Wasm. Think of it like the CPU target. So the first lesson once I started working with this and experimenting with this was actually the runtime environment, the CLI environment is actually really quite easy to get up and running and quite quick. The browser environment, not so much. So a few more points on the Wasm technology itself. Yes, you can run it in a browser. Yes, you can run from a command line. There are a bunch of tools. All the ones that I've found at the moment are all open source and free. The compiler I'm using is WAT to Wasm, and there's a bunch of tools that come with that. That's another open source project. And as I've learned more, probably the more popular tool chain is called Mscripten. And when we release this presentation, I'll have a whole bunch of links and resources for you to get access to. The reason I didn't use Mscripten was because it also had a dependency on Python and a dependency on NPM, the Node Package Manager, and I didn't really want to go down that path for either of those other environments. So I started using the compiler. Another tool I'm using, which is the, if you like, the runtime environment in command line is called Wasm. Again, there's a number of those sorts of things that exist that allow you to run a bytecode from a command line. And as I mentioned, all the tools that I've used so far have all been free and open source. And to me, that's a bit of a double-edged sword because there's often misinformation, often things are incomplete, often documentation is poor. But other than the browser experience, the experience has been quite good, including getting it up and running in free Pascal. All right, so I'm going to do a demo. Very simple stuff. So here is a WAT file. This is actually the equivalent of an assembler source file, if anyone remembers those days. Really simple. All it does is returns the magic number of 42. Yep, question, Roger. The font. You want the font bigger? I'm not sure how to do. Sorry, guys. We're just making the font bigger. There we go. How's that? Yeah, excellent. All right, so this is a really simple syntax. I don't fully understand it in terms of I couldn't write this from scratch. This is one that I've borrowed from somebody. It returns essentially a magic number 42. If anybody knows Hitchhiker's Guide, the number of the universe or whatever it is. The key point to call out here is this is the exported function name. Underscore start is the default. You can name it whatever you want, but if you don't name it something, the rest of the environments and the tool chains will be looking for an exported function called underscore start. It's a bit like the main function in a C program. So this WAT WebAssembly text file basically just returns number 42, which is not so interesting, but it does allow us to prove our tool chain, etc. So back to the command line. Not sure how I can make that bigger for you. Control mouse scroll. No, that works in a browser. Yeah. All right. So basically, I'm in a folder that has one text file, which is my Wasm text file, and I'm going to compile that to a Wasm file using my Wasm to my WAT to Wasm compiler, and I've just created some simple structures here. Sorry. Now, there are a number of command line switches and so forth, like most compilers. I'm just going to leave everything as default. So it's created this binary, this byte code, and it is 39 bytes in size. Interesting. If I try to view it, it's binary with our method name we can see is plain text. And basically, we can now do something with this binary. In terms of testing it, I'm just going to use my command line environment. And well, I'll just do run, and then I have to specify the interface, and the interface name is sorry, John? Better? All right, I'll just do that again. So Wasm is the runtime, and run is the command. Demo1.wasm is the bytecode binary that I just created. I is for interface, and start is the name. And so we return 42. Something else that's interesting is the inspect switch or option. And it allows us to basically look at the internals of the binary, including the exported functions, dependencies, and so forth. Interestingly, you can convert a .wasm file to a native operating system executable. I couldn't get that to work because I had a lot of dependencies and libraries that I needed to install. But in theory, what I saw is that you could take a .wasm file and convert it to a native Windows or a native Linux binary and run it without the runtime. Don't know why it's jumping. Okay, so just to recap that simple demo, we created a .wat, a Wasm text file, which is equal to the source. We compiled it with WAT to Wasm, which is part of a free tool chain. We executed it from the command line environment using the run parameter or the run option, and then we also did an inspect to see the contents of it. So at this point, to get to this point, it took about 4 or 5 hours. Most of the effort was about choosing the tools, finding the tools, getting the tools. All of that just takes time. Lots of reading, lots of posts, etc. But I still hadn't got it to a browser, which was one of my key objectives. Remember what I said about not liking JavaScript? Guess what? To run it in a browser, there's lots of JavaScript. A lot, actually, and this has been a problem. You load it as a library, and of course, being JavaScript, there's currently 4 ways to do that. I'm still trying to work out what the pros and cons are for each of those. It's complex, and to be honest, I haven't been successful at running my own WASMs in a browser, interfacing with the document model, buttons and controls and those sorts of things. And I'll show you what I can do in the browser and how that works. But in terms of an integrated piece of code that runs in a user interface, I haven't been successful at that. I know you can do it, but I haven't worked out how to do it. So that was the lesson 2, browser equals JavaScript. So my previous idea of just loading this .wasm file as an object tag or an applet tag wasn't accurate. So the model now looks a bit more like this. So we have the user interface in HTML. We have a whole bunch of JavaScript methods and interfaces and objects and all sorts of things. And then sitting behind that, we have one or multiple compiled Wasm objects. So just to give you an example, I'll show you what I'm talking about when we talk about JavaScript. So this is a demo project that I've been working on, and interestingly, the JavaScript was generated from Delphi to JS or Pas to JS. So it seems like this whole world of loading the Wasm binaries into a browser is so complex that actually one of the paths is to write it in Object Pascal in terms of loading the object and instantiating it and interfacing with it, and then converting that code from Pascal to JavaScript. This is what it generates, like lines and lines and lines and lines of code of JavaScript, horrible, not type safe, messy JavaScript. I didn't want to be in that world, and I'm still trying to work out how I can not be in that world. Interestingly, the HTML around that is actually quite simple. And basically, all the magic is done in that JavaScript library that I just showed you. Okay. So what I've been seeing is a fairly loud message to say that Wasm doesn't replace JavaScript. It supports it, it augments it, it adds value to it. People are moving compute-intensive modules and algorithms and those sorts of things from JavaScript to Wasm. The user interface, at least in a browser, is still in JavaScript or whatever other user interface technology you want to choose. You can well, the principle of being able to write your Wasm binaries in your preferred language still exists. The shared libraries still exist. There is some projects around where you can actually use a Wasm binary in like a C or a Delphi application. I haven't quite got to that yet. So just like we're loading Wasm binaries into a browser, in theory, although I haven't proved it, in theory, we can load a Wasm binary or bytecode into a Delphi application and call functions from it as well. So I'm thinking the idea of having, one set of Wasm binaries that are used for all sorts of purposes in a particular environmental application set. I did find this video editor, which is the user interface is created in JavaScript, and each of the video processes on the left-hand side, so grayscale, invert, etc., are all provided by an underlying Wasm library. And so this will manipulate or process the video, the recorded video. These are just a couple of screenshots. You can go to that link there and check it out yourself. But that's kind of like an example of where this technology is headed. All right, so just to quickly show you how you can get it into, or how I got it into a browser environment. So again, I started with a .wat file, a Wasm text file, and this particular one has a function called add2. It takes two 32-bit integers and returns a 32-bit integer. And basically, it adds them together. Real simple. I'm going to do the same thing as I did before, and that is to compile it. I'll make the font bigger. So there's my Wasm file for this next demo. In terms of the size, it is 44 bytes. And the HTML and the JavaScript that loads that up is here. So we're in the heading, in the head block, we got a script block, and basically we do this asynchronous JavaScript call to load the Wasm file here. This is one of the 4 ways to instantiate a WebAssembly object. And here we're defining a method variable from the exports in the instance. This is really simple. This is the only level I could get to work. And when the script block runs, when the document loads, it basically does a for loop and adds 2 numbers together and displays it onto the console. The other thing, when you get into a browser world, like many browser type web developments, is you need a web server. Otherwise, Firefox and all the browsers complain about the cross-domain security and privileges and those sorts of things. So I actually did load it up onto just one of our web servers. And very simple, just a bit of HTML saying demo2, check the output. If I go to function 12, I can see that the console output of the 2 numbers has been generated. I've been using Firefox. I don't have Chrome installed on this laptop. I have tried it on Chrome, and it obviously works. It works fine. Really, what I wanted to point out is the inspector and also the debugger, because you can actually see the contents and including the Wasm file and the WAT file that we use to create it. So I thought that's pretty interesting. It's actually doing like a reverse compilation because there is no WAT file on this web server. So that's the only way it could get it and display it. And there's the HTML. So I like the integration of that. That was helpful. Okay, so just to recap that, we created a Wasm file from a WebAssembly text file. We had some HTML code with some JavaScript functions around it. We needed a HTTP server to run it, and we can display it, albeit in the console, but within a browser. Google Chrome and Firefox worked pretty much exactly the same. Microsoft Edge required some configuration that I could not find the setting to change with some security permission to run WebAssembly. Could not work that out. So Microsoft Edge is on the out at the moment. All right, so Wasm from Object Pascal. So in terms of Delphi, there's no official support. There's no talk I've seen on the forums. If anyone's heard anything different, I'm keen to hear it. There was a promotion by Jim Keith supporting REM Objects Oxygen, which does support WebAssembly. And I did also think, and I read a couple of people talking about a connection between FireMonkey and Wasm would be kind of nice because you've got this cross-platform development, and then essentially you've got a cross-platform target as well. In terms of Free Pascal, it's officially supported. It requires some tooling. I did have to recompile Free Pascal compiler from source with a new target being WebAssembly. And actually, even though I sort of went, oh, what's this going to be like? There was a wiki page, which I'll share the link for. And it was actually pretty straightforward as long as I followed the wiki page. I've tested it from the command line. It can be used from within Lazarus. I didn't work out and I didn't explore how to do that, but I have seen some wiki pages and some other documentation on how to have WebAssembly as a target within Lazarus. And the other thing that keeps coming up, people are using Pass2JS, which is bundled along with Free Pascal as another option to generate JavaScript from Object Pascal. And as I mentioned earlier, we can also access Wasm bytecode objects, libraries from within Xes, which is something I'm interested to explore myself. So have a demo of that. All right, so here we have our familiar.dpr. And it's very simple, hello world. Just a simple 2-line console program. If we compiled that, it would be pretty straightforward. In terms of how we convert it into a Wasm object, as I said, I'm using Free Pascal, and in the process of generating a new WebAssembly target, it generated a binary called pp cross wasm 32.exe as part of that process. So that is the Free Pascal compiler that is now supporting Wasm as an output. So to compile that, that DPR file using that, And what it's generated is a .o file, which I guess is some sort of object file, and then the Wasm file. Just like before, we can use our Wasm program. And we can inspect it. And this time, we see down the bottom, our start exported library. And then we see a whole lot of other functions and dependencies that the compiler has brought in. So if we change that to run, so that did run, as you can see, the two strings, but I think the return code is not right or something like that. I don't recall what that error is actually. But you can see that it did output the two lines. Yeah, I don't recall. And to run that in a browser, that's now where I've found it to be extremely difficult. I've taken literally projects that are working and tried to reproduce them on another server, and just lots of errors, and it just doesn't work for whatever reason. Just needs more time, basically, more investment in my energy. So the question was, could it be the support files? I don't think so, because I've used other Wasm binaries, even just simple things from other sites and other other projects, and still just can't mount them into a browser. It's complex. Interestingly, Mscriptum that I mentioned before, when you compile, just like we did then, when you compile from a C source, it generates a HTML file with the required JavaScript to load that Wasm file in a browser. I didn't know that at the time. If I had known that, I might have gone that path initially, because of the difficulties. Yeah, and what I find in this area is there's lots of pieces. You know, everyone's got a piece of the puzzle, but you don't get a start to finish, and that's what's been difficult. So in terms of my effort, 80% of it has been trying to get these Wasm files running properly in a browser and interacting with the document model, being able to display that hello world message. I know you can do it. I just for me to reproduce it, haven't been able to work out how to do it. So just to recap what we did, we had a DPR file, really simple console project, single unit, compiled it with the free Pascal cross compiler to Wasm32 as a target. We ran it, we inspected it, and as I said, I haven't been able to get it to work in a browser. As I mentioned before, the Wasm environment is sandboxed, it's a virtual machine, it's secure. As it was originally designed, it didn't interact with any system objects outside of that. So Wasm, or WASI, I beg your pardon, is WebAssembly System Interface. And this has come along a few years later. And basically what it allows us to do is it extends the security model and the functionality, and allows us to interface with files and file systems, with sockets, clocks and timers, and all sorts of other things. It's currently a proposed standard. It hasn't been ratified as far as I know, at least at my reading. And it does not depend on any other technologies. The free Pascal compiler does support WASI. In fact, that target that I generated was a WASI compatible target or binary. But the question remains is what extent, what can we do, what is supported or not supported with the WASI interface, and also WASI within Free Pascal. It seems that lots of people are doing C++ migration to Wasm. Also, Rust is really popular. So that's how I actually came across Wasm, was researching Rust. So people doing Rust work or Rust development are often creating Wasm outputs. For me, what's next? If I had another month and unlimited time, I would get Wasm integrated into Lazarus as a compile target. I would solve this JavaScript integration problem, and not just I'm talking about copy paste text or script, but actually really understand the problem and which of the 4 methodologies is the best, or which one do you use in which situation. All of this just takes time. I'd like to work out how to load a Wasm binary and execute it from within a Delphi application. I think that'd be interesting. And I'd like to know what WASI functionality is supported at what level of the standard within Free Pascal. And I'd like to experiment converting, I don't know, some PHP code or C code or something else to Wasm. I think Wasm's actually quite interesting for server-side targets to replace things like PHP. And of course, user interface. How do I build a user interface that interacts with my Wasm libraries? After doing all this, my conclusions are, having started off this activity is, just hearing about it and not really understanding it. It's a really promising technology. It's cross-platform. It's supported by multiple browsers. It's open source. It's a W3 standard. But at the moment, for browser integration, it's really hamstrung, really limited by this JavaScript interface. And as I said, I don't love JavaScript, but even still, it's just complex. And I don't think anyone could disagree. There's some questions over the user interface support. How can you interact with the user interface? I've read some information about working with a HTML canvas, for example. Is that possible? I don't know. I think it's interesting for server side. Overall, it's still a maturing technology. And if you were thinking about building some sort of technology, some sort of website, and you wanted to run it in a browser, for example, and you wanted to use Object Pascal as your language of choice, I wouldn't recommend it at this point in time. I'd be looking at the other tools, which we actually have someone talking about at the next session, I think, which is where you're writing in Pascal in an IDE and converting to JavaScript, which is almost like an assembler in that way. So thank you. Any questions or thoughts or experiences? It's definitely something to try. John. Yeah. So the question back. Oh. How do you go for debugging Wasm?
Question. So 80 people from now.
The question is does it look like, or is there a possibility for Wasm to interact in both directions with JavaScript? Is that what you're asking, John? That's where I think the Lazarus example comes in, because essentially there is cross-compiling. There is a way to do callbacks. It's a bit like if you wrote code. I haven't explored it, but it does look like Free Pascal, Lazarus, for an x86, debugged it, had it working, and then ran it on an ARM processor as another target. That's how I imagine that would work. I don't see a way of doing like could you write an API, compile it to Wasm, and run it at the server side? It could be there. It could be one of the free tools that I'm not using. Absolutely. In fact, I have read about a project. Sorry, I have read about a project that is taking like a general.
Jason, we can't hear the questions online. Could you repeat the questions for us?
Yeah, I have been repeating the question.
Library around that. Oh, there was a long
I think what you're going
a long period of someone talking, and we didn't hear any of that just before you answered.
The question was. Oh, okay. So it's Andrew, isn't it? To resolve Andrew was making the comment about whether I tried ChatGPT to resolve my interface to JavaScript question, and was sharing his experience of converting a C function or C code that took 5 days to actually break, and being able to resolve it, or Jeff being able to resolve it in, was it 5 minutes? Almost? Very quickly. That's what we were discussing, Paul. Okay.
Jason.
Any questions from the online group?
Yes, Jason, I was wondering, all these JavaScript functions that are there, right? And if you write an application for the browser, right, you have a decent portion of logic in the application that is exposed. It doesn't matter if it's JavaScript or if it's like TMS turned into JavaScript, or the compiler that is available for free Pascal. I always wonder, how do you protect that stuff? What is actually your way of protecting it? It seems to me that Wasm could be a good way to protect your intellectual property. But then again, it creates that binary, creates that text representation of the binary code. So you could still reverse engineer what you've written in the first place in Pascal, possibly.
That's true,
Is that
Matthias.
correct?
Did everyone hear that question here? Yeah, so I had the same thought, and basically, how do you protect your intellectual property? I haven't found or seen any encryption, securing, signing of Wasm objects.
Yeah.
You know, technically JavaScript is open to anybody who wants to spend the effort and read it and interpret it. I think Wasm is going down the same path.
Yeah. And especially if I compare that now with our current application, which is using DataSnap, there's a lot of check happening on the client side to avoid silly questions to the server, right? To be told by the server, bugger off, right? This is not correct, do something else instead, right? Or do this instead, right? So if you write an application in JavaScript or in TypeScript or in Wasm that is doing all these checks on the client side, right? You're exposing a lot of functionality to the user, right? And if I press F12 and go into my browser and I change what my JavaScript code is doing, I could actually do all sorts of silly things with my browser application. So after all, what is the reason that Microsoft, for example, sticks to something like Skype? Or why do we have a picture editing software, Paint.net? Where is the place for the desktop application in comparison?
Yeah, it's a good question. It's a good question. I'm not sure I have the answer. Yeah, anyone else got any thoughts about Matthias's?
I mean, yeah, this is a discussion with everyone here in the group, right? Because we're all getting asked, why can't your application run in a browser? And I always try to convince or to tell them what the risks are, right? And most people don't get it.
Yeah, I agree. There are third-party technologies that allow you to run your applications in a browser, either as they are, using the HTML5 canvas, or with additional libraries added from within even the Delphi tool set. This is a different world. You know, once you get hold of a Wasm binary, bytecode, I don't like calling it a binary. It doesn't feel right. But once you get hold of that, you can completely reverse compile that to a C program within the tools that I've been using. You can take a Wasm file, create it in Object Pascal, and convert it to a C code. And then I don't know what you do with it. So yeah, it's a slightly different world. As I said, I've not read anything about signing, security, and even take the intellectual property question out of it. How do you know your Wasm object is your Wasm object? How do you sign it? And that I haven't seen or worked out yet.
So for me, when I looked at that stuff and I thought, how can I avoid that ugly JavaScript? I heard about TypeScript, and when I read that it's actually from Anders Hallsberg, I thought, maybe that is a solution, because we've got data types on our browser things, but I haven't really found out how much of that is supported in a browser already. Does anyone of the group here know how much of TypeScript can be used in a browser already?
Wouldn't it be all of it?
So all of it?
My understanding of TypeScript is it's Objective-C-like. No? It is just JavaScript. Okay. We're just having a discussion here. We're saying, Adam's saying that TypeScript is just like JavaScript.
TypeScript is compiled down to JavaScript, you use the typing once it is compiled.
What was that, Paul?
I believe TypeScript becomes JavaScript when it's like compiled or whatever, transpiled, I suppose. So you once it's sort of become runnable, it doesn't have actual types anymore, I believe.
That's correct.
Yeah, I agree with Paul. That's correct. What TypeScript gives you is tooling on top of JavaScript, so you actually get type checking while you're writing the code.
Yep. But that still means that in the end, you could go into your browser if you know how and change the parameters, change the call, and does something with the application that the developer had not in mind. If you understand JavaScript. Yep. Yeah. And people don't.
I think you have to think about it. You know, where is your security in a web application? And it's not just the front end. You know, you can't let the back end do something that's not meant to do. So, you know, you're checking parameters and things on the REST calls and what have you, and security in that on the back end.
And as a result, Vincent, the whole thing gets much more chatty than it used to be.
Well, I mean, I don't think it's any different to any client server application. Like if you have a multi-tier Delphi application, you're still doing security checks on different tiers.
Side, yes. Yeah, but I can actually avoid silly round trips in my DataSnap application and say, hey, that's not ready for being posted, right? And if I do that, I have a bit of business logic on the client side as well, right? And now in a browser application, you would definitely want to avoid that stuff, right? You wouldn't want to do that, right? And so in that case, I'm doing more requests back to the server to find out that I should ask something else instead.
I think people have I'm not sure what the word is, but there's this kind of perception, I guess, that the JavaScript is really slow in the browser, and it would be if you're trying to do image manipulation or what have you. But if you're just trying to do like form validation and what have you before they click submit, you know, or when they click submit, it's plenty fast enough. So I don't really see a problem. It's, you know, of course, you know, if you're writing a back end, a REST server, for example, you'd be remiss to not put security checks and sanity checks on parameters and things like that. You know, you write safe code basically.
Okay, thanks.
Thank you, everybody, for a really interesting conversation. Vincent, Matthias, it sounds like we need to have another conversation at some point about the whole world of applications in JavaScript and browsers. I don't have all the answers. I'd hope that we could just compile our Delphi Object Pascal applications to Wasm and run them in a browser, but that's not the case, is basically the conclusion. However, from a server-side aspect, I think it's closer. I think it's more interesting and more useful today.
Question for you, Jason?
Okay, Adam's just suggested or offered that there is a product that allows you to work or connect Wasm to Node.js. So that's something to look at. Server side.
There's another question. I think it was Brendan.
No, it's me, Scott Holmes.
That's right.
Yeah. Jason, or has anyone else heard whispers from Embarcadero about whether there's going to be built into Delphi, like a build to or deploy to Wasm?
So I didn't hear a question. Is that you, Vincent?
No, that wasn't
Scott?
me.
That's Scott. Scott asked if we know anything about Embarcadero maybe supporting Wasm in the future. And Jared Davison posted something in the chat about a plan that they had back in November 2020, where Wasm was on the horizon for a research project within Delphi. But there was no statement made that they had any intention, but it was actually identified in November 2020 as something they would like to look into.
So interesting. Really I haven't read, of all the things I've read, I haven't read that Embarcadero are going to do anything with Wasm.
Well, no one knows if they have done, but it was actually mentioned in a roadmap slide that Jared quoted in his chat entry. Yeah.
Okay.
But it would be
Thank
really
you.
difficult for Embarcadero to do that as a commercially viable project unless they had the GUI all working, and didn't look like there was a path to make a GUI work under Wasm.
Yeah, but
Alright.
they've had success with deploying to other platforms. I mean, you know, Linux, iOS, Android. So maybe there's a way for them to do this. I mean, there's no way I could work out how to do it, but you know, that's they're in the business of deploying to platforms. So.
Rem objects have a link to the DOM in their implementation. Oxygen, Elements ID.
Gentlemen, we're having trouble hearing the conversation, and we're at time now, so I guess we can keep. Pardon? Oh, okay. Well, I'm finished anyway. Thank you.
Well, you're welcome. Thanks a lot for your presentation. Now, let's have a little bit more of that discussion. I mean, everyone else can go into his well-deserved lunch break, but I wonder, Embarcadero has tooled up with lots of third-party components in the past, right? And kind of brought other stuff in. So imagine they would bring in something like TMS Web Core, right? And license it with TMS. And then they would actually be able to support the Wasm model in the TMS application that you built with Delphi. Would that be a solution or a way forward to protect some of your IP in the browser?
Yeah, it would, but it's not enough. From my point of view, it's not enough for Embarcadero to spend the money. They need to bring forward the apps. That is what they're good at, which is, you know, native platform, cross-platform apps.
Yeah. They did a poll a few years ago, like a customer survey, and it was all about basically the WebAssembly and do people want to run VCL or FMX apps on the web browser. We don't know the outcome of that research study, but they were obviously seeing if that was something people were interested in as customers. Yeah, so the toolchain Embarcadero, they use LLVM, and it's able to produce Wasm if they so desire to do it. My speaking with Marco about this previously, he was concerned about the runtime library for it.
Yeah.
And that was the biggest hurdle as he saw it, rather
I guess
generating code. Yeah.
There's a major barrier to running UIs from Wasm in that you need bindings to some sort of host. So you need an engine to run Wasm, which is, most of them are a command line tool or a browser. And they don't have bindings to the Windows API, for example, to run UIs. So it would need that they create a host environment that can interact with the OS, UI facilities, and that would be a massive undertaking for Embarcadero to do when they're stretched already. I can't see it happening, to be honest.
Yeah, you'd pick something like Wasm.
Can I just jump in here? We're just going to go for lunch here in Sydney. Can I just confirm what time next presentation starts?
The time is actually at 1:15 p.m.
1:15. Thanks very much, guys.
You're welcome.
Hey guys, we're saying this just couldn't be done by Embarcadero, but if we go back years ago, we never would have thought they would have been able to deploy to iOS and OS X and Android and Linux. I don't see it as being, impossible being something that should stop this from happening. They've done the impossible before.
I agree with you. Rem objects have done it, and they're a much smaller outfit than what Embarcadero are. They have got the bindings to make it work with the DOM. My problem with it is not Delphi, right? So Oxygen's a different language. Although it's very similar, you can't use your code. You've got to change it in some way. So it's sort of a showstopper. But I think it just shows that a company that's got a motivation to do it can make it happen.
Personally, I would love to see Embarcadero get more involved with John Essendon, who's going to be talking next, I think. He's done insanely great stuff with Cortex Pascal. built an IDE that's basically Delphi IDE. He's built the language compiler, the debugger, just amazing work. So there are those kind of people out there that can do this stuff. But I would imagine that typically you would try and, you find something and buy it and then modify it and get it into the product. And they've done that before. I mean, FMX wasn't built internal to Embarcadero. I think it was built externally, and then they brought it inside.
We do have a last presentation today with David. And since David is an employee of Embarcadero, we may actually ask him some questions about that stuff, right? If he can confirm that there's still some research ongoing on Wasm, let's say, right? And doesn't say that that he doesn't have to confirm that they are doing something, that they will come out with something about it, but it just says we are still interested in it, or let's say the questionnaire has brought to light that our customers don't want it or don't need it, and that's why we've abandoned it. He's on it.
I think I think it was the Brisbane Symposium. I talked to Marco about this when he was there, and at the time, I don't know what year that was. Probably about 2015 or 16 or something. It's a long time ago. His comment at that time was it's immature, as in the support for Wasm, etc. But I think I heard him say more recently that that's not his opinion at the moment. It's definitely a valid target platform, and it's like a stable or a mature target platform that could deserve interest. So I don't know. I think we'll just wait and see. But I don't think the platform's going to go away.
I see Wasm for desktop applications much like Electron, in that Electron is a host environment that has UI bindings, or it actually uses a DOM really. So I'm not sure how a Wasm environment could be creating native window applications if you want, using the Windows API. I can see it hosting a browser like Electron does, but.
Yeah, I'm not talking about it doing VCL. I'm talking about it doing a. I'm maybe more interested in doing DOM-based stuff. But
so browser-based stuff.
Yeah, browser-based. But you could still emulate, like with say FireMonkey, because FireMonkey has a driver interface into it, so you can like write a driver for a particular target display system. Like, for example, they had Apple's has a metal interface, and Windows has the direct, what they call DirectX or something like that.
FireMonkey for DOM.
Or FireMonkey for DOM, or its own intermediate canvas that just draws inside whatever you get, pixels canvas or whatever. There's a bit of ways of doing it. Back to protecting your IP.
Yeah.
I don't know that your executable protects your IP if you're giving it away. If you keep it on your server, it's safe. I think all these Delphi machine code executables is probably just as safe as anything else. It's just probably a bit more. The tools to reverse engineer are probably not as easily obtained.
Yeah, I think the hurdle is higher, right? Whereas in a browser, you press F12 and you're up to the source code.
Yeah.
And you figure out what you want to do with that call, and you change the call.
Yeah, it's the same with things like C#. If you've got the DLL compile from C#, you can easily convert it back to pretty much the same code, or code that's good enough to use. So,
yeah, there are obfuscation tools for C# and what have you, and for JavaScript as well. Minified JavaScript is quite hard to understand. But if you try hard enough, you can work it out, I suppose. I just posted a link in the chat. There's some efforts to do obfuscation of Rust's transpilation to Wasm. But it's a bit like minified JavaScript, and you get back valid Rust code, but all the variable names are different, and yeah. So trying to follow the logic when you've got randomly named variables is quite difficult.
That just makes me think of the sites I'm at, we minify our JavaScript code. It's just a matter of you run a utility, takes JavaScript and it squashes it down, takes that white space, whatever, just reduces the amount of data text sent across, to make it faster. But when Jason showed us that JavaScript, it wasn't minified. I wonder if there was an option to do that, or if it always comes out like that. Jason, do you know, is there, like, I mean, this that JavaScript's being generated on the fly or whatever, but do you know if it's always like that, or if there's a way to minify it?
You're talking about Jason Tolley?
Yeah.
He may actually be gone in his lunch break.
Okay.
And at this stage, we've got Jared, Vincent, you, and me involved in the discussion in our lunch break. That.
I would say, as far as minifying that JavaScript, that's something you can do on the server side, or in deployment. So when you deploy your application to your web server, you minify it as part of that process.
Yeah. There was also, by the TMS study group that we had, there was an option that you could actually obfuscate, but actually minify it and obfuscate it at the same time when you deployed the TMS application for the browser, right? So
something you really should do if you're sending out Electron apps, which TMS is, because it's quite easy to actually look at the code for an Electron app.
Yeah. But that's why they've got their own version, right? They've got a own virtual machine for them to work, right? Which is not as bulky as Electron. It was MyTask or something like that, or which you can write an application that, and they showcase that with a image editor, right? That was running as a desktop application and in the browser at the same time with the same source code, just by compiling it into a different project.
Yeah.
Right.
It's not rocket science. I mean, Electron is not rocket science. Electron is basically just a host application that exposes some endpoints or some functions that you can call from JavaScript, and hosts a JavaScript engine like the V8 JavaScript engine or SpiderMonkey or whatever. So, I mean, if you think of Electron using Wasm in that scenario would be the same sort of thing. I mean, if it was easy, everyone would be doing it, but but it's not rocket science. I mean, there just has to be a reason to do it, I guess.
Yeah.
So for TMS, their reason was to be able to use Pascal, I guess.
But as far as I understand, Jason, this is just something emerging, and they're still working on some of the specification for Wasm, and it's
been around for quite a while now, and it is quite mature in the browser space. Where it's immature is the other tooling, like for example, the free Pascal stuff is quite basic still.
You posted that link for Can I Use? And it's amazing how many browsers do support it by now.
Yeah, and for a while now too. I mean, that Can I Use chart has kind of been compressed, so they use ranges of versions.
Yeah.
But I mean, so we're on Chrome 115 right now. But if you go and hover over like Chrome 57 when it was introduced, that was in March 2017.
Yeah.
So it's and so basically, pretty much all browsers apart from IE, which is dead, and Opera Mobile and KaiOS, don't know what that is. Pretty much all of them support Wasm. I mean, usually you'll see these little note squares with a number. It'll say like disabled for this or that. But when you look at the Wasm support in browsers, it's pretty much ubiquitous now.
Mhm.
So it's really the tooling that's that's the issue at the moment, I think.
Yeah.
So I guess for like if you look at Delphi targeting Wasm, like what's the objective? You know, what are you trying to achieve with it? You know, I mean, you're certainly not going to have like sysutils and classes.pas and stuff. You know, being fully ported. It would be partially or parts of it. You know, or a specific runtime library for that target. I think. Yeah. I don't think it's quite the same sort of target as targeting Mac OS or iOS or something like that.
Yeah, I mean, you might be able to do more of it if you're targeting WASI, the systems interface.
Yeah.